Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be understanding a pair of linear equations. We have already seen in the previous video that what are linear equations in one variable. In this we'll be having linear equation in two variable, and then we'll extend the logic to find the solutions for pair of linear equation with two variables, right? Okay, so let us take a small example. For example, if I have an equation which says that x plus y, let me just reduce this. Okay, so if I say that I have two variables, one is x and the other is y, and there is a sum between it, and this value is equal to say 8, right? This is one of the linear equation, example of linear equation with two variables. Why? Because both x and y are variables here, right? They can be equal, they can be non-equal also, they can be different also, we don't know. And this is the only equation we have been given. And suppose somebody asks you that what is the solution? What is the solution of this equation? Then do remember that we do have the solution for this equation, although it has two variables. But the thing is that we'll not be having unique solutions or only one solution. There could be many or infinite solutions. For example, I just need the values of x and y, which will satisfy this equation. When I say satisfy this equation, what do I mean by that? By substituting the corresponding values of x and y, whatever I'm assuming, the LHS must be equal to RHS, right? That's the meaning of being satisfying the equation. So I'm randomly taking one value for x, which is 1. We know that if x is 1 and y is added to it and the total is 8, definitely the value of y would be 7, right? I need not to solve that. It's very, very simple. 1 plus 7 will make it 8. So can I say 1, 7, this pair, 1, 7, this is how usually it is written when there are two variables. So 1 represent the solution for x and this 7 represent the solution for y. So 1, 7 is one of the solution of this particular equation. I can have many more. For example, I can have 2, 6. So 2 and 6 will be the another solution, right? Then 3, 5 will be another solutions, correct? Here I am taking only positive values. I can take the negative values also. For example, I can take the value of x to be say minus 3. In this case, the value of y has to be 11 so that their sum will become 8. So minus 3, 11 is also a solution, right? I have taken positive, I have taken negative. I can take fractions also. For example, if I take the value of x to be 1 by 2, right? So the value of y would be what? 7.5, which effectively we can write it as 15 by 2. We can write 7.5 as 15 by 2. So 2 or half and 15 by 2. This is also one of the solution. You can check. If you add 1 by 2 and if you add 15 by 2, 2 is common denominator. So the numerator 1 plus 15 will be added, which will make it 16 by 2 or equal to 8, which is nothing but equal to RHS. So this is, this way I can have infinite many solutions, right? So if the equation, linear equation has two variables and no more conditions are given, then we can have infinite solutions. The solution may contain integer, it may contain some fractions, rational number, etc. Anything, right? Any real number kind of thing. Now, if I introduce one more equation which have the same two variables, right? Say this is one of the equation. I'm just naming this as the equation number 1. If I'm having say another equation, let me just remove this, or let me have another equation which say that x minus y is equal to 2. This will be my equation number 2. And again, the question says that solve this. This particular setup wherein we have two variables and two different equations, then we say that this is called pair of linear equations in two variables. Pair of linear equations in two variables. That is the topic for today's session, right? So how do we solve a linear equation in two variables? Now in this situation, what will happen is that there are three possibilities of the solution. Either we will not be getting any value of x or y, which will satisfy both the equation simultaneously, right? Now For example, this is the solution for the first equation. It's okay. But is this the solution for the second equation as well? Of course not. You can see that 1 minus 7 is not equal to 2. Right? So this is not my solution for this pair of linear equation. For this pair to be the solution, or the solution, if anything is the solution for this pair of equation, then it must satisfy equation number 1 as well as equation number 2 both simultaneously. Right? So from here, if I just want to make any guess, then I can say that one of the solution for this equation is what? 6 or say 5 and 3. This is one of the solution. Right? You can see that x is equal to 5. If I take, then the value of y has to be 3. Surprisingly, you will see that this particular solution, which is satisfying the equation number 1, is also satisfying equation number 2. If I put the value of x to be 5 and the value of y to be 2, value of y to be 3, then 5 minus 3 will make it 2. This is the only solution you will find that satisfies both the equation. So questions for this question, the answer is 5 and 3, or the value of x has to be 5 and the value of y has to be 3, right? There is no need to worry that how did I find a 5 and 3 out of the blue. We'll be getting a method to solve these equations, right? Or to simplify this equation to get the corresponding values of the variables, right? But one thing is sure that 5 and 3 is satisfying both the equation. So when I say solution for the pair of equation, I mean to say such kind of solution which when substituted in the equation 1 and equation 2, in both the cases, LHS will be equal to RHS, right? So I hope you have got the fair idea about what is pair of linear equation in two variable. Now let's see that what are the ways through which we resolve or solve these equations to get the corresponding values of the variables, right? So let me just remove everything here. So usually we have three ways of solving the linear equations. We'll be discussing at length only two ways, which are algebraic form. The first form, or the third form I would say, is the graphical representation. The graphical representation way I'm avoiding right now, because for that we need to have a basic idea about how the graphs are plotted. This is not the objective of this video, so I'm just leaving it apart. Although for all practical purpose in CAT or any other NP exams, you will not be needing to draw the graph, right? Of course, you should know how to draw the graph, but as I said that is not the scope of this particular video, right? We'll be dealing it at length so in some other videos, or maybe when we'll be discussing coordinate geometry or the basics of coordinate geometry. Right now, we'll be dealing with two different methods which you must have gone through your school days. One is the method of substitution and other is the method of elimination, right? So let me take some equation. Maybe I'm taking an equation that x plus 2 of y is equal to say 10, and the next equation I'm taking is that 3 of x minus of y is equal to say 5. I'm just making two equations. Now I need to solve them to get the corresponding values of x. One way is you take the method of substitution, right? Say this is equation number 1 and this is equation number 2. What we do in substitution is that we try to convert one variable into another variable from taking any one of the equation, and after converting we substitute that variable in the other equation so that these two variable equation get converted into single variable equation, and we know that how to solve the single variable equation. From there we get the value of that single variable, right? So let's do that, then you'll be understanding a lot. For example, let me take the first equation. I just want that what will be the value of x in terms of y. So I just want to transpose this 2y in the RHS. So I'll be getting 10 minus of 2y, right? What I'll be doing is that I'll take this value of x and substitute in the equation number 2, right? I'll take this value of x as 10 minus 2y and will substitute in the equation number 2. So wherever there is x, it will be substituted by 10 minus 2y. So here, this thing will become what? 3 times of 10 minus of 2y minus of y, right, is equal to 5. Further, this will be 30 minus of 6y minus of y is equal to 5. Further, we can say that this is 30. Now here we can see that both are same term, right? Both are like terms, not same term, they are like term. Why? Because the variable factor is same. So here we can say that minus 6y, or we can say that y is common here. So minus 6 and minus y, they together will make it minus 7, right? So it will be minus of 7y is equal to 5. Now we need to find the value of y. Now here we can see that this equation is now being reduced to single variable, right? Because x has already been substituted in terms of y. So 7 of y, if I take it to the RHS and this 5 at the LHS, it will be like this, which is nothing but 25 is equal to 7y, or dividing both the side by 7, I'll be getting the value of y, which will be equal to 25 by 7. So I have got the value of y, which will satisfy both the equation, and correspondingly I need the value of x. How do I get? Very simple. I have already taken the value of x of y. So I can substitute this value of y here to get the corresponding value of x. So here it would be 10 minus 2 times of 25 by 7, which effectively is 10 minus 50 by 7. So to make this as a denominator 1, so what I'll be doing is that I'll be multiplying this by 7. So it will be 70 minus 50 by 7. Now the denominator is common, right? So it will be 70 minus 50, which comes out to be 20 by 7. So the value of x is 20 by 7 and the value of y is 25 by 7. This becomes the solution, 20 by 7 and 25 by 7. This is how usually we write the solution. Now, how do we ensure that this is the solution and I have not made any mistake? One way is, of course, you put these values of x and y in any of the equation and test whether LHS is equal to RHS, right? So let us test it for the equation number 1. Substitute the value of x and y as 20 by 7 and 25 by 7 in equation number 1. So let's see that what do I get. We just change the color. Okay. Right. So here x, it is 20 by 7 plus y is multiplied by 2 times. So it will be 25 by 7. Right. Let's see. We are just testing the LHS portion. So here it would be 20 by 7 plus of 50 by 7, which comes out to be 70 by 7. I've just skipped one portion that both have the same denominator. So the numerator will be added, which is nothing but equal to 10, which is nothing but equal to right hand side. This. That means this is the solution which is satisfying equation number 1. This will also satisfy equation number 2 as well, because that is the logic. In fact, that was the purpose to find the solution for x and y. So here we can see that if I substitute here, it would be 3 times of 20 by 7 minus 25 by 7. Let's see, this is the LHS. So here it would be what? 60 by 7 minus 25 by 7. Again, 7 is common. So 60 minus 25 is what? 35. So 35 by 7 is 5, which is nothing but equal to RHS. This will always happen. In fact, this must happen. Otherwise, whatever calculation you have done, you have got the wrong solution. If this is not happening, it must satisfy both the equation. Correct? So this is 99% cases for MBA entrance. This is how the two equations will be given, right? And you have to find the solution. Usually the questions are not that simple wherein you have been just given the equation you have to solve. This is the intermediate step to get to the answer. Usually the question will be in the word format. You have to frame those equations. After framing the equation, you have to do these particular things to get to the solution, right? Now, one question is that, do we always get the solution? The answer is no. There is a chance that in spite of doing this particular process, you will not be getting the values of x and y, right? So such kind of pair of equation, we say that there are no solutions, right? And secondly, or the third kind is, you will be getting many solutions, right? Or you'll be getting infinite many solutions. Even there are two sets of equation. In that case, we call it infinite solution. Infinite solutions, right? These two right now I'm just avoiding for the sake of simplicity, because as I said that 99% cases you'll be getting those two equations. After solving them, you'll be getting a value of x and a value of y. How to get that? This is the process. This is one of the process which we call the method of substitution, right? Wherein we take one variable and substitute it into the form of other, put it into the next equation, make it in a single variable equation, solve to get the value of that variable. Once you have got one value of one of the variable, the second variable will automatically be obtained, right? This is one way. Is there another way, which is usually I suggest that you should always be doing the next method. The reason being is that the equation may not be that simple as I have taken here, right? The equation might have the coefficient which is larger or maybe a bit complicated. In that case, rather than substitution, the elimination method is usually suggested by most of the people, and I'll also suggest it that you should do the elimination method. Although there is no difference into it, you'll be getting the same kind of answers, but the thing is that elimination method works better. So what is elimination method? I'll be using the same example to explain it. Okay. So in elimination method, what we do is that we try to, first of all, we decide on your own that which variable we want to eliminate. Out of two, we want to eliminate one so that only one remains. And since there is only one variable which remains, then we will automatically get the value of that variable. And later on, we can substitute in that value in any of these equations to get the other variable. So suppose we decide in this equation that we have to eliminate y. So what I'll be doing is that I'll be focusing on the coefficient of y in the first equation. It is 2. Here the coefficient is -1 in fact, right? Or you can take 1 also, that doesn't matter. I want that the coefficient of y should become same in both, right? So one way, of course, is that if I multiply this equation by 2, I'll be generating another equation without distorting its value. So another equation will come for 6x minus of 2y, which is equal to 10. This becomes my, say, third equation. Now, just ignore the second equation. Just focus on equation number 1 and equation number 3. Here we can see that the coefficient of y in both the cases same. But in the first case, it is with the plus sign. In the second case, it is with the minus sign. So what we do is that if I add both these equations, right? If I add equation number 1 and equation number 3, what will happen is that the like terms will be added. Let us add. So if I add x plus 2y, the LHS portion, and the LHS portion of the third equation is, 6x minus of 2y, and the RHS portion will be added like this. This will be 10, and this is also 10. We are adding these two. The like terms will be added. So x plus 6x will make it 7 of x. 2y minus of 2y will be eliminated, or they will cancel each other. So we'll only be getting 7x. This is equal to what? 20. So the value of x is equal to what? 20 by 7. So if you can remember, we got the same value of x, right? If you want to ensure, then you can just go reverse this video, go maybe a couple of minutes back, you'll be getting the same values of x there. Once we have got one value of x, then definitely the next value of x can easily be identified. What we can do is that since this value of x must satisfy this equation as well as this equation, we can substitute this value of x in either of these equations, right? So let us substitute in the first equation. So we'll be getting 20 by 7 plus of 2y is equal to 10. After substitution, again, you can see that there is one equation and single variable, which we already know that how we can solve it is quite easy. We can just transpose this on the RHS. So 2 of y will be equal to 10 minus 20 by 7, right? Which comes out to be what? This becomes 70 by 7 minus 20 by 7, which will become what? 50 by 7. This is 2 of y. Again, we need the value of y. We don't need the value of 2 of y. So what we can do is that we can divide both the side by 2. So I'll be getting y, which will be equal to 25 by 7. So this is the value of y and this is the value of x. In both the case, as I said, you'll be getting the same values. But the thing is that you can see that by this, we are saving a lot of time. And at the same time, more complicated questions can be solved by this method in the most easiest way, right? So I hope you have understood both the method. The first was the substitution method. This method is known as method of elimination, right? This method is known as elimination method. right? So is it necessary? Yes, it is quite necessary. Do I get number just by knowing this? Of course not. As I said, these are intermediary steps. You must know how to solve the two equations. The questions will mostly in the form of word problem. You have to read the word problem. You have to generate the equations, and after generating the equation, this mechanical activity has to be done to get to the answer, right? So let us check that how do we generate the equation for two variables from the word problem. So now I'll be taking say four or five word problems, and I'll solve all of them in a very detailed format so that you understand how to get to the formation of the equation, and after that we'll be using either substitution or elimination, mostly elimination method, to solve them for the values of the variable, right? So let me just remove everything from here and give you the questions. Let me just copy this question. Okay, so I'm taking two questions, right? We'll be focusing primarily on the first question. What it says, and try to understand it. It says that there are 10 students in class 10. They took part in mathematics quiz. If the number of girls is 4 more than the number of boys, find the total number of find the number of boys and girls who took part in the quiz. Now here, if I look at the question, it's saying they find the number of boys and girls. Do I know the values of number of boys and girls separately? Of course not. So there are two unknowns, right? So let me assume that the number of boys is X and the number of girls is Y for the time being. If there are two variables, I must have two conditions also, right? For such kind of thing, what happens is that the number of variables, if there are number of condition is equal to number of variable, then only we can get the exact value or unique value or one solution for the variables. So what are the two conditions? This is the first condition. How many students are there? 10 students. And students composition is what? Boys and girls. So we can say that total number of boys plus total number of girls, these two together should be equal to 10. That's the meaning. What is the second condition? The second condition says that the number of girls, that means Y, is 4 more than the number of boys. So can I say number of girls is 4 more than the number of boys? So if the number of boys is the X, we have to add 4 here so that this must be equal to 1. This is the second equation, right? This is can be solved easily by substitution method because the equation is very, very simple. So what we can do is that we can substitute. This is the equation number 2. This is equation number 1. We can straight away substitute the value of Y in the first equation. So what do I get? I'll be getting X plus the value of Y will become X plus 4, which is equal to 10, which will make it 2X plus 4 is equal to 10, right? Then 2 of X plus is equal to 10 minus 4, which is equal to 6, or the value of X will be 6 divided by 2, which is nothing but 3, right? Once we have got the value of X, we can substitute this value of X here to get the corresponding value of Y. So the value of Y would be what? 3 plus 4, which will make it 7. So we have got that there are 3 boys and 7 girls. We can cross check. Is the total number of students 10? Yes, 3 plus 7 is 10. Is the number of girls 4 more than the number of boys? Yes, it is. So we have got the right solution, right? So here we can see that the important thing is not the solution of the equation. The important thing is the formation of the equation. The formation of the equation is always the tougher part compared to the solution of the equation. Okay, so let's move to the next question. Next question says that there are 5 pencils and 7 pen. Their cost is rupees 50. That means the total cost is rupees 50, whereas 7 pencil and 5 pen, their cost is 46. We have to find the cost of 1 pencil and 1 pen. How many unknowns are there? 2 unknowns. Do I know the value of these unknowns? Of course not. So what I should do, the first thing is that we have to substitute the unknowns with variables. So let me assume that the cost of 1 pen is X and the cost of one pencil is X and the cost of 1 pen is Y. Why I'm taking two different variables? Why I'm not taking both to be x? Because it's not sure that cost of one pencil is equal to cost of one pen, right? It can be, but I'm not very sure. I just want that both are different, so I should be substituting them with different variables. Now I have introduced two variables, so I should have two conditions. What is the first condition? It says that the cost of 5 pencils added with the cost of 7 pen is equal to 50, right? So what I can do is that cost of one pencil is x, so the cost of 5 pencil is of course what? 5 times of that. Similarly, cost of one pen is y, so cost of 7 pen would be what? 7 times of y. Their sum should be equal to rupees 50. This is my equation number 1. On a similar lines, we can read this and frame this equation. This is my equation number 2, right? Now the task is to solve them. One way is of course the substitution, but here we'll be using elimination. Let us assume that we want to eliminate y. How do I proceed? Usually what we want to do is that we want that these coefficients should become same, right? So if nothing comes to your mind that what should I multiply, use the thumb rule. What you can do is that the coefficient of y from the first equation is the number you have to multiply to the second equation. And the coefficient of second equation of y is the number you'll be taking and multiplying the first equation, right? So if this is 7, multiply the next equation by 7. If this is 5, then multiply the first equation by 5. So you'll be generating new equation. You'll be getting 5 into 5, which is 25 times of x. 5 into 7 will make it 35 times of y. And that is equal to 5 into 50, which will be 250. This is say my equation number 3. In this case, it will be 49x plus this will become 35y. This is the reason we have done it. We want that the coefficient of y should become same so that after subtracting the y component or y term will get eliminated, right? And at last it will be 7 into 46. So I'm just taking help of calculator because I don't want to make any silly mistakes. This is equal to 322. This is my question number 4. Just observe equation 3 and 4. If we subtract this equation number 3, if I perform equation number 4 minus equation number 3, what do I get? This is 4, so it will be 49x plus 35y minus of 25x plus of 35y. This will be equal to what? 322 minus 250. I could have done 3 minus 4 also. In that case also we'll be getting the solution. But I saw that this is higher than this. So it makes sense that this should be subtracted to this. Now here we'll observe that this is plus 35 and this will become minus into plus of 35, that is minus 35. So these two will get catch. And 49x minus 25 will be getting 24 times of x, and that is equal to this difference is 72. So clearly the value of x will be 72 divided by 24 because we have to divide both the sides by 24. So here the answer would be 3, right? The answer would be 3. So we have got the value of x. Now how to get the value of y? Simple. You just pick any of the equation, substitute the value of x there. So let us take the equation number 1. So here it would be 5 times of 3 plus of 7y will be equal to 15. Again, this is 15 plus of 7y, which is equal to 50, or 7 of y will be equal to 50 minus 15. So I'm just transposing 15 here, which will make it 35. So the value of y would be what? 35 divided by 7, which is equal to 5. I'm dividing both the side by 7. We have got the value of x and we have got the value of y. So the cost of one pen is 3, pencil is 3 and the cost of one pen is 5. What you can do is that you can pause this video and try to see is this value satisfying both the equation or not. Just pause the video and check yourself. Okay, I hope you must have done it, right? And you have identified that 3 and 5 is satisfying it. You can do it now. This is 15, 35. This will be how much? 21. And this is 25, which will add up to make it 46, right? So this is how the word problems are given. We have to frame the equation and solve it. Let's take a few more examples so that you understand that what exactly, what kind of question or what types of question we get in pair of equation. So I'm writing few questions. Let me take these questions all questions together. Let us take all these questions together. What you can do is that you can pause this video, take 4, 5, 10 minutes, whatever you feel like, solve it, and then proceed with the video for the solution. Okay, let's take the first question. Here it says that the difference between the two numbers is 26 and one of the number is 3 times the other number. Find them. You have to find two numbers. Do we know any one of them? No. So we have to introduce two variables. So let us assume that the two numbers are x and y. It says that the difference between the two numbers is 26. That means x minus y is equal to 26. If I'm writing this equation, I am assuming one thing, which is a fair assumption, and that is the value of x has to be greater than y. Then only x minus y will be getting a positive value, right? Further said that one number is 3 times the other. That means the greater number has to be 3 times the smaller number. So greater number is x, which should be equal to what? 3 or 5. This is my equation number 1. This is my equation number 2. Clear, simple substitution will work. We can substitute the value of x is equal to 3y in the first. So I'll be getting 3 of y minus of y is equal to 26, which will make it 2 of y, which will be equal to 26. Dividing both the side by 2, I'll be getting the value of y to be 30. Substitute this value of y here. I'll be getting the value of x. Here it will be 3 into 13, which is nothing but equal to 39. Right? So the two numbers are 39 and 30. And you can check. Their difference is 26 and one number, this is 3 times of the other. Fair enough, right? Okay, you should have got these values also. Next, the coach of a cricket team buys 7 bats and 6 balls for this rupees. Later, she buys 3 bats and 5 balls for this rupees. Again, we have to find the cost of each bat and ball. This is very much similar to the previous questions for pencil and pen questions we did, right? We don't know the cost of each one of them. So let us assume that the cost of bat is x and the cost of one ball is y. So the cost of 7 bat and 6 balls together, it will be 7x plus 6 of y. That should be equal to what? 3800. This is my equation number 1. Next equation would be 3 of x plus 5 of y, which is equal to 17500. This is, sorry, 50. This is my equation number 2. Right? Now, let us assume that we want to eliminate, or let us decide that we want to eliminate y. What we can do is that we can multiply this equation completely by 5. That is the coefficient of the second equation. Similarly, this entire equation has to be multiplied with the coefficient of the first equation, which is 6. So I'll be regenerating this equation in a different format, wherein it will be 5 into 7, that is 35x, plus this 2 together will make it 30 of y, and here it would be 1900. 19,000 it would be. Say this is equation number 3. This will become how much? This will be 18x plus of 30y. This was the only objective because these two will be together, will be same, will be equal to 1750 multiplied by 6, which is 10500. Say equation number 4. Clearly, equation number 3 RHS is more than equation number 4. So what we can do is that we can perform equation 3 minus equation 4. So this will get cancelled. This 2, we have to take the difference. So this will be minus sign. So I'm getting in the LHS 35 minus 18, which is 17 of x. And here I'll be getting 8500. Dividing both the side by 17, I'll be getting the value of x as 8500 divided by 17, which will be equal to what? 500. So we have got the value of x. How to get the value of y? We can substitute it, right? Let us substitute in this equation or in this equation. Let us substitute in the second equation because the coefficients are smaller. So here it would be what? 3 into 500 plus 5 into y is equal to 1750. 5 of y would be equal to what? 1750 minus of 3 into 500 is 1500. So this will become 1500. right? So I'll be getting the value of 5 of y as 250. Dividing both the sides by 5, I'll be getting the value of y as 50. So this is the value of x and this is the value of y. So cost of each bat and ball would be what? 550 respectively. Here enough, right? You should have also got the same answer. Now let's take the fourth question. Again, read the question. Here it says that 5 year hence. 5 year hence means what? 5 years from now. That is, it is talking about the future. 5 year hence, the age of Jacob will be 3 times that of his son. 5 years ago in the sense in the past. From now, 5 years back, it is talking. 5 years ago, Jacob's age was 7 times that of his son. We have to find their present age. There are two people, Jacob and son, and his son. None of their present age is known, right? So suppose this is the present age is not known. The conditions are talking about either 5 year in the future or 5 year in the past, right? So 5 year in the future in the sense each one of them will be 5 year older in the future, and 5 year in the past they will be 5 year younger, right? Say this is Jacob and this is his son. The present age of both is not known. I'm just assuming that their present age is x and y. So if Jacob's age is x, then 5 years from now, his age will be plus 5, whatever his age is today. For example, if my age is say 35 today, 5 years from now, that is in 2029, my age would be 35 plus 4, which is 35 plus 5, which will make it 40. Correct? So can I say whatever the age of Jacob, 5 years from now, the age would be x plus 5, and the same thing will happen for son also, because everyone will be aging in the same way, in the sense their age will be added 5 times, 5 year hence for all the people who are alive today, right? Be it me or you or anybody else. In the same logic, 5 years ago, everybody was 5 years younger. So Jacob will also be 5 years younger. So his age should be his present age minus 5. Similarly, son's age should be y minus 5. Now let us read again the condition. Let's say that 5 years hence, that is about the future. This is about the future, right? This is about the past, and this was about the present. So in the future, 5 years, Jacob's age was 3 times. That means this value x plus 5 was equal to 3 times the age of his son. This will happen after 5 years. But 5 years ago, the relation was that Jacob's age was 7 times. That means 5 years ago, we have to take this age. The age of Jacob was 7 times the age of his son. Again, we have two equations, right? So what we can do is that, first of all, let us rearrange the equation. So I'm just focusing on this. I'm rearranging. So what I'm getting is that I'm putting, or I should take the variables on the LHS and everything else on the RHS. So here it should be x, and this 3y would be on the LHS, will make it minus 3 of y. 3 into 5 will make it 15. This 5 will go here. So it will be 15 minus 5, which is equal to 10. This is my equation number 1. Similarly, this thing can be done as x minus of 7y. This 5 will go at the RHS. In the RHS, this will be minus 35 plus of 5. So we'll make it minus of 30. Rearranging them, what we can do is that we can multiply this equation by say minus 1, so that we get rid of the negative sign, or we can retain this also. Let us retain this, right? Now, it's quite clear that the coefficient of x is same. So we can clearly eliminate. What we can do is that we can perform equation 1 minus equation 3. So equation 1 is this minus equation 2. This is equation 2, guys, right? So this is equation 1 and this is equation 2. Minus 7 of y will be equal to what? 10 minus of minus 30. You can clearly see that x will get cancelled. This is minus 3y. Minus into minus will make it plus. This will be 40. So now 4 of y is equal to 40. So we'll be getting the value of y as 40 by 4, which is equal to 10. Right? What we can do? We can substitute the value of y in one of the equation. So here it should be x minus 3 times of 10 is equal to 10. So the value of x would be what? 10 plus 30, which will make it 40. So Jacob's present age is 40 years and his son's present age is 10 years. This is my answer. And you can cross check. In the future, 5 years from now, the age would be 45, the age would be 15. Clearly, this is 3 times, then 15. 5 years before, this age would be 35, this age would be 5. Clearly, this number is 7 times of this. Both are matching, right? So let's take the last question. Let me remove everything. The last question is that the sum of the two-digit number and the number obtained by reversing the digit is 66. The digit of the number differ by 2. So the two conditions are given about a two-digit number. We have to find how many such numbers exist. Okay. Okay. In such kind of question, if I write two-digit number, say 73, this is two-digit number. This and this both are single digits. But the place of 7 is at tens place. The place of 7 is at tens place, right? You can write this as 7 into 10 plus 3. This is how we should break 73. Fine. So if I assume the two digit to be x and y, right? X and y are digit, but x place is at tens place. And I want to ensure that whatever the value x take, it should be a single digit, but same for y. But the way they are written, they must represent a two-digit number. So rather than taking this way, I should be preferring this way, right? So let us assume that 10x plus y is the two-digit number, where both x and y are digits. They are single digits, right? So if I assuming that x is equal to 4 and y is equal to 3, in that case, this is a way wherein a two-digit number can be formed. It would be what? 4 into 10 plus 3, 43 would be formed. That's the reason I'm taking it this way, wherein I'm assuming that the value of x is at the tens place and the value of y is at the unit place. I hope you have understood this now. Correct? Next is, this is my assumption. So a number formed by reversing the digit. Reversing the digit in the sense, what will happen? Now, if the number is in this particular way, the new number will be this. Y will become at the tens place and x as a digit will go to the unit place. So the number after reversing would be what? 10 times of y plus of x. Correct? So the sum in the sense, the addition of these two. The like terms will be added. So it is 11x. This terms will be added. So it is 11y. This is equal to 66. Clearly 11 is common. So we can take x plus y is equal to 66, or the value of x plus y will be equal to what? Dividing both the side by 11, I'll be getting 6. This is say equation number 1. Right? Further say that the digit of the number differ by 2. They differ by 2. Does it necessarily mean x minus y is 2? It could be other way around also, but we need just one more equation. So I can say that x minus y is equal to 2 is my second equation. Now we have got the two equation. Then we can solve. So let me write them again. X plus y is equal to 6. This is my equation number 1. X minus y is equal to 2 is my equation number 2. Let us add them because it's simple now. The coefficient of y in both the cases same. In one case it is plus, in the other case it is minus. So adding them, I'll be getting 2 of x, y will get eliminated, and here it is 8. So the value of x will be equal to 4. Once I substitute the value of x is equal to 4 in this, I'll be getting the value of y is equal to 2. So what is the number? That number. The number is 42, or it could be 24 also. That's the beauty of this question. Why I'm taking 24? Because if I take 42 as that original number, the reverse of this will become 24. This sum is 66. First condition is satisfied. The second condition is also satisfied. The difference of the two digits is 2. So 1 is 4, other is 2. So the difference is 2. It is not saying that the difference of tens place digit and unit place digit or tens place digit minus unit place digit is 2. It's simply saying the difference is 2. So it could be either way. The tens place digit can be higher or the unit place digit can be higher. Their difference has to be 2. Because of that reason, this is also one of the possible solution. You can see that if the original number is 24, the reverse of it will make it 42. The sum is 66 and the difference is also 2. That's why the question says that how many such numbers are there. So both these numbers are there and we have to take care of this once we have got this solution. Right? So that's it for today's solution, this video. Now you must have understood that what is pair of linear equation. There are two methods. One is substitution and elimination. You can use either of this. The important thing is not the solution of the linear equation. The important thing is that how do you transform the word problem into the equation format. And once you have done, the mechanical activity of solving it to get the values of x and y is the only thing required to get to the final solution.